Hi everyone, here I continue on the lesson. This is topic 31, application for rotational motion. So as I told you, we didn't study and we didn't teach about rotational motion, but in terms of velocity and acceleration and in terms of going back uh, using integral, we can do questions. So for rotational motions, if I have the rotational velocity, okay, so if I have angular velocity, then if I do integral of angular velocity, I can go back to the displacement, which I show it with theta, and it is radian. Okay, so if I do acceleration, derivative of acceleration, so integral of acceleration, then I can go back to angular velocity. So I used to have this as displacement. If I can just refresh your mind, I used to have S as my displacement, and then I did derivative of S, and I said, okay, that's velocity, and then I did derivative of V, and I said this is acceleration. This is for linear. This is for linear when I have, for example, I have a car which is moving from point A to point B. Okay, so I go from displacement by derivative I go to velocity, and from velocity by derivative I go to acceleration. The same here. If I have theta, so it is my displacement in radian or angular displacement, which I don't, maybe I don't change my position, but I'm just moving around the circle. Okay, so for example, I start here and I go back here, I go back, say, several times. Okay, this is angular displacement. Okay, so I can tell how much move I had in terms of radian, how much move I had in terms of degree. So when I say I start here and I go back to this, it will be 2 pi radian, or it will be 360 degree. Okay, but still I am in the same position. Okay, so if I have that, then if I do the derivative of this, it will be omega, which is angular velocity, and if I do derivative of omega, it will be alpha, which is angular acceleration. Totally the same as the totally the same as the other linear one. Okay, so now as we did, if I do integral, I can go back. Okay, so if I do integral, I can go back from acceleration. Okay, I can go back to V, and I can go from V to S. The same here. Now if I do integral of this, I go back to this one, and if I do integral of this, I go back to this one, because integral and derivative, they are opposites of each other. Okay, so now you can use this to answer this question. A centrifuge starts from rest. A centrifuge is something that goes around, so like a circle. The move is like a circle, angular. Okay, it starts from a rest. So it starts from rest means v velocity 0 is 0, because at the beginning there is no velocity. Accelerate is alpha 385 radian per second squared. Find the angular velocity. Okay, so vt is integral alpha t dt, which is integral 385 t, it's t here, I missed that part, dt. Okay, now what is the answer? Questions from this part are very easy because the functions are very easy. Okay, so it is 3.85 t squared divided by 2 plus c. What is c? So 385 t squared divided by 2 plus v0. Okay, what is v0? 0. Okay, so vt is 385 t squared divided by 2. Done. This is the velocity. Okay, so I can just look at the lesson the same as linear. The same as linear, I want to repeat. If I have displacement, I do the derivative, I go to velocity. If I have velocity, I do the derivative, I go to acceleration. I can do opposite. Integral of acceleration is v, integral of v is s. Not the same here. Derivative of theta, angular displacement, change in angular is omega, angular velocity, derivative of that is angular acceleration. Sorry about that. Now I can do the same and I can go backward using integral. So I can have this, now I can have this, and by integral I can go to this, by integral I can go to this. Okay, now I'm using the same here. Okay, so now it says find angular velocity and total number of revolutions after 10 seconds. What is angular velocity after 10 seconds? So you have to say v at 10. Okay, so v at 10 is 3.85 divided by 2 times 100. Okay, which is, if I can find the calculator, yes, so it's 3.85 times 100 divided by 2. Okay, which is 192.5. Okay, I underline that, check that. So this is 193, 193, so it's velocity, yes, radian per second. Okay, so after 10 seconds, then it says how about revolution? So how many revolution? How many revolution means how many circle. See, if I start from here and I reach to the same point, this will be one revolution. Revolution means how many circle, how many 2 pi radian. Okay, so I can find how many radian then. How can I find that? Okay, so first I have to go to theta. So theta t is integral 3.85 divided by 2 t squared dt, because it's integral of v. Okay, so now the answer is 3.85 divided by 2 times t cubed divided by 3 plus theta 0. I don't know theta 0, but I don't need. I can show you why I don't need. Okay, so this is the answer here. So it is 3.85 divided by 6t cubed plus theta 0. Okay, now it says how many revolution after 10 seconds. So I can do theta 10 minus theta 0. Why? Because it says after 10 seconds. It means wherever I start, what about after 10 seconds? So it doesn't matter where do I start. That's why I don't need to know theta 0. So after 10 seconds, so maybe I start here after 10 seconds. Maybe I start there after 10 seconds. Okay, maybe I start here after 10 seconds. Maybe I start here after 10 seconds. Doesn't matter. Okay, so I don't need to know theta 0. So I can do, the answer is theta 10 divided minus theta 0. So it is, the answer is 3.85 divided by 6 multiple 1000. Okay, so I can find the answer here. So it's 3 point, or I can do it step by step. So plus theta 0 minus theta 0, and this cancel. So the answer is 3.85 divided by 6 times 1000. Okay, which is this one. That's this radian. Okay, so here is radian. But I said how many revolution. So you say 6.4.1, 641.6 forever. Okay, because I don't want to round and round and round. I use my answer up to the end. Okay, so I do not round and then I use my answer. No, I round at the end. So I say this one. Okay, this is radian. So I say, okay, 2 pi radian is 1 revolution. This many radian is how many revolution? This, I'm looking for that. 2 pi radian is 1 revolution. This radian is how many revolution? And I am doing the, I'm finding x. So this is proportion. Okay, so x is this times this divided by that. So x is 641.64 ever divided by 2 pi. And the answer is, so I don't touch my calculator, I can divide it. So I have the answer, so I divide by bracket 2 times pi. Okay, that's 102.1. So it is almost 102 revolution. Okay, see, questions here are very easy. You have in final exam, very easy, but pay attention. Pay attention, I say how many significant digits. What is the number? When I was marking, I saw some of you, for example, you saw, for example, 2 and you used 3 when you were doing the question. Pay attention to the numbers, okay? So if I give you acceleration, you can give me velocity by integral. And then from velocity, you can give me theta by integral again. So I do this, then I find after 10 seconds. Then I find radian, and then from radian, I go to revolution. How do I go to revolution? I say 2 pi radian is 1 revolution because it's 1 circle. Radian is 1 circle. When I start from here, I reach to the same point after 1 circle. Okay, and then I can find the answer in revolution. Now I can go to this question. A body is moving at this rate. Velocity is 1.5 t squared meter per second. So it's not revolution, it's just linear. For example, like somebody is walking, for example. Okay, find the distance that it moved in t seconds if s is 0 when t is 0. Okay, so I have to find st. St is integral 3 over 2 t squared dt, which is 3 over 2 t cubed divided by cubed plus s0. Okay, but it says s0 is 0. Okay, this is 0. So it is 3 over 2 t cubed divided by that. Then I can cancel this and say, okay, this divided by 2. Okay, so find the distance that it will move in t seconds. Yes, this is in t seconds. So this is the distance in t seconds, which is, what is the unit? Meter. Make sure to add the unit. Okay, so if the question will be like this and the computer should mark you, make sure to answer correctly with the unit. Okay, so how many meter? Yes, you answered this here. Okay, so I have the velocity and I can go to distance, and I know s0 is, so this is my c, so c is 0. Okay, so a part in a machine has initial velocity of this. So initial velocity means v0. V0 is 15.8 centimeter per second and has an acceleration given this. Acceleration is t cubed minus 25.8 centimeter per second. Write an equation for the velocity v and evaluate the velocity at 5 seconds. Okay, so what do? I have a, I want to go to v. So v is integral t cubed minus 25.8 dt, which is t power 4 divided by 4 minus 25.8 t plus v0. What is v0? It is given to you. Okay, so it is t power 4 divided by 4 minus 25.8 plus 15.8 centimeter per second. Okay, this is centimeter per second. So here is the acceleration is centimeter per second squared. Okay, so this is missing in the question. Question is wrong. Okay, centimeter per second squared. So I have acceleration. I want v. I use integral. I need v0. I have v0. I substitute. Then how about after 5 seconds? So means you have to find v at 5 seconds. So it is 5 power 4 divided by 4 minus 25.8 plus 15.8. And you can find the answer. Find the answer. The answer will be centimeter per second. Okay? So very easy. If I have acceleration by integral, I can go to velocity. How about this? A centrifuge, this is angular. The centrifuge starts from rest, so means V0 is 0. And accelerate with this. So acceleration alpha is 3 radian per second squared. Find angular velocity after 12 seconds. So very easy. Angular velocity is integral alpha t dt, which is integral 3 dt, which is 3t, plus v0. V0 is 0. Okay, done. So then after 12 seconds, so v after 12 seconds is 36 seconds, because I do 12 times 3. So 36. What is the unit? The unit is important here. Radian per second. The unit is very important. Questions of this kind, very easy. But the unit is important. Okay, so, and unit, the number of significant digits, those things are important. Now I go to topic 32. Topic 32 is the finite integral. When I have integral, but from where to where? When I have limit for integral. I mean this. For example, I tell you, I can just show you here. See, I want the integral of x dx. You know it is x squared over 2 plus c. Yes. But then I tell you from here to here. It means I am finding area under the curve from 2 to 3. From 2 centimeter to 3 centimeter. From 2 unit to 3 unit. From 2 meter to 3 meter. 2 kilometer to 3 kilometer. Okay, so here I'm not finding the function. I am finding really the area under the curve from somewhere to somewhere. Okay, now we go back and read. The definite integral is an indefinite integral, but I have boundaries from where to where. I have condition, I have limit from where to where. So when you have to do the question, you have to consider you have something from somewhere to somewhere. Okay, how do you do it? For example, here I can tell you, given the derivative is x, okay, what is initial functions from 2 to 3? Okay, it means I want the initial function, but I have boundaries from where to where. How do you do that? Okay, see, I have the derivative, so here it is. dy over dx is x. Y prime is x, right? So y is integral x dx, right? Which is, you can find the answer, x squared over 2, yes? But here, I don't want that. I say from 2 to 3, means I don't want you to find me the function. I want you to give me a value. So the value is area under the curve, under this curve from 2 to 3. Where is the curve? So the curve is here. This is y equal x, and this is, for example, 2, and this is, for example, 3, and I want this part. I am looking for that part. Okay? So very easy. First, you have to find the integral. First, let me give you just steps. Forget this and find the answer. Okay, so it is x dx, which is x squared over 2 plus c. Then forget c. You don't need c. I can show you why. Okay, then you can find the answer for 2. Then you can find the answer for 3. 3 and 2. Because I said from 2 to 3. So first forget top and bottom. First forget those boundaries. Find the integral. And then substitute 3, substitute 2. So what happens when you substitute 3? So it is 3 squared over 2 plus c. It is 2 squared over 2 plus c. And then find this one minus this one. So it's 3 squared over 2 plus c minus 2 squared over 2 plus c, which is 9 over 2, 4.5 minus 4. Right? 9 over 2, which is 4.5 plus c minus, minus 2 minus c. C and c cancel. That's why I say you don't need to consider c. Okay? So if I give you question like that, so 2 to 3 x dx. First forget this. Second, find the integral. What is the integral? Okay, so integral is x squared over 2. Then don't write c. You don't need c. Because you saw that c cancelled. Okay? So plus c minus c, you don't need c. So you do from 2 to 3. Okay? From 2 to 3, so you have 9 over 2 minus 2 over 2, which is 7 over 2, which is 3.5. Am I right here? No, it's 4 over 2 then here. So 4 over 2, so it's 5 over 2. Okay, so it's 2.5. So it's 5 over 2, which is 2.5. So here is 2.5. So 2.5. 2.5 what? 2.5 unit squared, because I am talking about area. Okay, but here I don't need to mention this because I'm going to mention this in topic 33. Okay, so if I have the finite integral means I have boundaries. The finite integral, I have boundaries, I have conditions, I have limit. First, I forget my boundaries. Find the integral antiderivative. I don't need to include c. Then I substitute the top. C, I write the answer. I forget 2 and 3. I write the answer. Then I say, okay, from 2 to 3. I show it this way. And I don't include c because c and c cancel each other. So I don't need it. Okay, so I put 3 and I put 2 and then I find the answer. Okay, 2.5. So look at this. Okay, see, it's showing you this way. Okay, so now I can do this question. What is this? So, okay, first forget 2 and forget 4. Forget them. Okay, don't think about them at all. Okay, what is the answer? The answer is x cubed divided by 3. Do I need c? No, I don't need. Why? Because I have from 2 to 4. What is the answer? 4 cubed divided by 3 minus 2 cubed divided by 3. Which is 4 minus this divided by 3. What is the answer? 4 cubed is 64, if I'm right. Yes. Minus 8. Yes. So it's 56 divided by 3. Which is 18, 2 over 3. This is a mixed fraction. I can keep it this way or I can go to mixed fraction. Depends if I say how you answer me. Okay? So, that's it. So, if I have boundaries, I forget them. Then I just find the integral and then I say from what to what. And I don't need to include C, I just need to find the answer. How about here? How about this? Okay, for this one, I need to forget this. I need to find the answer. So the answer is 3 comes out. So the answer is this, which is 3e power x. I don't need C from 0 to 2. Okay, so it's 3e power 2 minus 3e power 0, which is 3e power 2 minus 3. Because e power 0 is 1. That's it. This is the answer. Okay? It says 4 significant digits. So now I can use my calculator. So 3 times e power 2 minus 3, which is 19.167. I underline that, check that, it is almost 19.17. This is the answer. Because it says 4 significant digits. So pay attention to significant digits. Okay? So here, so I forget if I have boundaries, I find the integral and then I substitute top first minus bottom next. Remember, I put 2 first and then I put this one next. Otherwise, it will be opposite. It will be negative. Okay? So look at this. See? Here. You forget A, you forget B, find the integral. So the integral of this is capital Fx. Integral of lowercase is capital. Okay? I do capital. And then I don't need C. Then I substitute B first and then I substitute A next. Okay? So FB minus FA. Remember, top first. Otherwise will be opposite. Okay? How about here? Here, I forget 1 and 3. Then I do 7. Okay, 7 comes out. X squared dx, which is 7 over 3 x cubed. Right? X cubed. I don't need C. So I say, okay, from 1 to 3. Okay, so it's 7 over 3, 3 cubed minus 7 over 3, 1 cubed, which is 7 over 3 times, okay, so I can cancel. So I can say, okay, so I can, okay, so which is this, okay, I can step by step minus that, okay, which is, okay, it's 7 over 3 times 27. Yes, it's 27 minus 1, which is 7 over 3, 26. Okay, what is the answer then? Yeah, which is 62 over 3. Okay, you can find the answer. So this is very easy. So if you know integral, easy. Okay, I stop here because for this one I have to teach you something. So here I stop and then I continue after. Thank you so much for your time and I continue after this.